This lesson is about redox reactions and finding oxidation states, or oxidation numbers, from Wiley section 14-1. We'll go over oxidation reduction reactions and rules for assigning oxidation numbers. We've seen chemical reactions release and absorb energy in the form of heat. But energy can also be released in the form of electrons that are moving across a wire. Electrochemistry is based on something called the redox reaction. The word redox is a combination of the words reduction and oxidation. Got to take a side note here. A word formed from the combination of two other words is called a portmanteau word. You might have heard the terms chillax, spork, or guesstimate. Redox is a portmanteau word. Okay, back to chemistry. Redox reactions involve a transfer of electrons from one reactant to the other. The process oxidation is a loss of an electron when a reactant loses electrons. Reduction is when a reactant gains electrons. A way to remember this is use the memory device oil rig. Oxidation is loss, reduction is gain. So how do we know if a reactant has gained or lost electrons? We use something called oxidation numbers. It's a bookkeeping device that allows us to keep track of which reactants have gained and which have lost. Oxidation numbers are kind of like charges, but the two are not quite the same. Ions have oxidation numbers, but also neutral covalently bonded atoms have oxidation numbers. Something that's challenging about redox reactions is we have to remember that electrons have a negative charge. If an atom loses an electron, its oxidation number goes up because it has lost a negatively charged particle. If an atom gains an electron, its oxidation number goes down. That's why we say reduction is a gain of electrons. An ion's charge and oxidation number will be the same. That's pretty easy. But as we said, covalently bonded atoms also have oxidation numbers, and those are a little more challenging to figure out. Remember, as we go through this section, oxidation numbers are merely a way to keep track. Every atom will have an oxidation number. Section 14-1.3 has a series of rules for assigning oxidation numbers. You will not receive this table, but memorizing a little bit plus common sense and practice, you'll be able to assign oxidation numbers every time. Let's go over some rules and practice a couple examples. The oxidation number for pure elements, such as diatomic gases, is 0. H2 gas, iron, chlorine gas, carbon all have 0 oxidation numbers. When bonding, oxygen atoms usually have an oxidation number of -2, except when they make peroxides like H2O2, then oxygen's oxidation number is -1. Group 1A ions, +1 charge, +1 oxidation number. Hydrogen atoms usually have +1, except when they bond with group 1A elements, then hydrogen has a -1 oxidation number. Not very common, but it does occur. Group 2A ions, +2 charge, +2 oxidation number. Group 7A, the halogens usually have -1. Fluorine is always -1, but you may see exceptions in the other halogen atoms. Okay, this next rule, very important, because the previous rules only cover a few of the atoms. The sum of the oxidation numbers of all atoms in a molecule or a polyatomic ion equal its charge. So use this rule to find oxidation numbers of the atoms not covered by the previous rules. Let's work some examples. We'll start with water. The oxidation number for oxygen, -2, hydrogen, +1. Both these atoms covered by the rules. This is pretty straightforward. Water is a neutral molecule, so the oxidation numbers of the atoms should add up to 0. -2 for the oxygen, plus 2 times the +1 for the hydrogens do in fact add up to 0. That's a good check, and this rule is going to help us further in our next example. Let's do one a little bit more challenging. So what's the oxidation number for nitrogen in the ammonium ion? Its formula, NH4, it has a +1 charge. We know hydrogen is +1, but nitrogen is not in our rules. So what do? We're going to use that last rule to help us figure out the oxidation number for nitrogen. There's our formula. Each hydrogen, oxidation number of +1. There are 4 of them, so the total contribution to the hydrogens is +4. The polyatomic ion has a +1 charge overall, so the sum of all the oxidation numbers should equal +1. That means nitrogen has to have an oxidation number of -3. -3 plus the 4 hydrogens gives us a +1 overall. So nitrogen has an oxidation number of -3. Finding oxidation numbers is a vital first step in understanding how redox reactions work, and when you balance redox reactions later, the first thing you'll have to do is find oxidation numbers for the reactants and the products. As always, contact Corey or myself if you have questions. The main job of your course mentors is to enable your success in these courses. You can email us at the group inbox at chemistry@wgu.edu, or you will find contact information for your individual course mentor in your course of study.